So, guys, similar polygons. You know similar polygons. Hey. You know similar polygons right here are going to be same shape, different sides. Okay. So, we're going to talk a lot about how are polygons similar and how are they related. So, we're going to look at some similarity statements. We're going to talk similarity statements first. Second thing, we're going to talk about things that correspond to each other. We're going to talk about corresponding lengths. Also going to talk about corresponding angles. We're going to look at the relationship of perimeters and perimeter on the inside or outside. Area inside, outside. Okay. And then we're going to decide whether polygons are similar. We kind of did that in the last section. We kind of talked about, oh, those sides aren't proportionate, therefore not similar. So we'll talk about that. Okay, guys. Shouldn't really need it. Maybe, but you shouldn't. Okay, because most of the figures are going to be drawn for you now. You don't really have to plot a ton in this section. Okay? All right, similar figures. We already know that they're figures that have the same shape, but a what? Okay, we talk about transformations. If I transform something, it's a rigid motion, but it doesn't. It changes to a non-rigid motion when we start doing what with the sides? And what kind of movement changes sides for us? What kind of movement? Dilation. So a similarity transformation right here definition is a transformation followed by what, kids? Dilation. And then corresponding sides. I'm just going to draw something real quickly here. Make sure that we're okay with this. Let's just draw maybe two rectangles, one a little bigger than the other. Those look kind of similar?
Yes, sir.
Okay, let's do this. Let's just say that these are similar to each other, and maybe I call this A up here, B, C, and D, and I call this F, R, A, and U. Okay, never mind. All right, talk about corresponding parts. Angle A is probably going to match angle what? F, okay, so here's the deal. We're going to talk about corresponding parts. All the angles, what would B correspond to here? C would correspond to the, and D would correspond to U. And then we're also going to talk about sides being proportional. So we would say AB, the side AB in the little rectangle corresponds to which side? FR? And I could go on for all of these, but these are all going to be equal. RA would correspond to what? Well, BC. Okay. And notice I'm always putting the little ones up here. What would CD correspond to from the smaller one, kids? A to U. And then finally, DA would be the same as what? So, you know, you got to put corresponding sides together. I think you know how to do angles, and that shouldn't be anything that's difficult for you. Okay? So, we're looking for sides that match up. We're looking for angles that match up. Here we go. Guys, using similarity statements, I'll blow this up here quickly. It says in the following diagram, triangle ABC is similar to what? Want to talk about the significance of what's given up here, okay? This part right here, very important. The order with which they write stuff is very important. If you notice in that first triangle, when they say given triangle, what? Triangle ABC is congruent, or I'm not congruent, but it is, what's that little symbol squiggle mean? Similar to JKL. What's listed first in the first triangle? A. What's listed first in the second triangle? J. Okay, so it means A has to match what? A has to match J. Okay, that order matters. So side BC, if I looked at the order up here, side BC would have to correspond to what given this? All right, so that's important. Okay. So let's find the scale factor from triangle ABC2. Okay, well in part A right here, I'll put part A over here. Here we go. Guys, in part A, you're basically comparing sides. You want to compare sides right here, okay? We have to take a side from what first, kids? The cool part about it is this. How many sides do you know in triangle ABC? All three. So pick one. Which one do you want to work with? 21. I like 21. Okay. So I'm going to say the ratio for this is 21 to, what's the 21 going to correspond to then in triangle JKL? 28. Now the question becomes at this point, for the scale factor, Find a scale factor from ABC to, oh, I should back this up. I should back up. I got to double check this. I think that the way they worded this is goofy. I want to talk about that. We're going from the little triangle to the what? Big triangle. So if you remember scale factor, a scale factor is, I should rewrite this. I really should rewrite this. I'm going to write down a scale factor. I'll abbreviate SF, has to be an image length over the what? Okay, so I should back up here, kids. If we're going from ABC to JKL, we're going from here to here. Are we getting bigger or getting smaller? Bigger. So what would the image length really be there? 21 or 28? Which one's the new figure?
28.
28. So it should be 28 over what?
21.
21. Now, can you think of values that simplify into 28 and 21?
7.
7 will go into both, right? How many times will 7 go
3.
into the first one? 4. How many times into the second one? 3. Okay, so what's this going to become? Be 28 over 21, which is going to simplify to what again, kids? 4/3, right? So scale factor, are you okay with that? Yay or nay? Okay. Part B then. Part B talks about what are the pairs of congruent angles. Well, they already have given to you up here. You could say part B, angle J has to be congruent to what? Angle A. How about your angle K? What's that congruent to? Angle K has got to be congruent to angle B. They're both listed second. And then C and L. Angle C. And this is write the ratios of the corresponding side lengths in a statement of what? Proportionality. Okay? It's pretty easy to do. It's really easy to do, kids. Here's the deal. You would say 21 is to what? Okay, and I think that what they want us to do, I don't know if they want us to use side lengths. Do they say use side lengths or just sides? Side lengths. Okay. So one way to do this, kids, would be, all right, you would say A to B, A over B is the same as what, kids? What's AB correspond to? JK, so you could say AB over JK has to equal, give me some other values. BC over what? Give me one more that would work. AC to... I have a quick question here, kids. If I would have followed this rule up here for scale factor and this down here, would 4/3 have been the same way, or would you have gotten different values? This would have been flipped. So in all cases, all these should simplify to what over what? 3 over... Check this out. Does 21 over 28 reduce to 3/4 when you divide both by 7? Does 27 over 36 reduce to 3/4 when you divide everything by 9? What's 27 divided by 9? What's 36 divided by 9? Okay. Does 36 over 48 reduce to 3/4 when you divide everything by 12? 12 into 36. 12 into 36, how many times? 3. 12 into 48, how many times? 12 into 48, how many times? Guys, I'm amazed by the number of things that aren't math related going on right now. Okay? Look, if not going here today. Stressed out enough as it is. All right? I'm amazed by the number of conversations, reading, art going on, and we're not listening. Okay? I just am absolutely amazed some days that people just choose not to engage. Blows my mind. All right. So, are you okay on these first three? Maybe we should have a pop quiz right now over all this. What do you think?
Let's do it.
Do it?
I'm not very good at these quizzes.
Okay, well, let's everybody maybe find our focus and pay attention to what's going on here, all right? Look, One of the compliments I get all the time is you actually sit down and you explain it to us. And then when people don't take advantage of getting explained to them, I get frustrated with that, okay? So let's pay attention, please. All right, talk to me about this. It says finding a what? Corresponding length. It says in a diagram, triangle what? GHM is similar to triangle HKL, okay, which means GH would have to correspond to what? Okay, so I'm just going to do this. I'm going to color code this a little bit. GH is where? Well, that wasn't a very good decision to put blue on blue. Way to go, Parson, moron. How about this? Don't these correspond to each other? Give me another side that corresponds to each other. Ooh, that's pretty. Say again. HM and KL. So HM is what value?
18 and 27.
12 would match the X, and then right here, 18 would match what?
27.
Okay. It says find the value of what, kids? Okay. Anytime you start looking for finding a corresponding length, you need to set one of these up. We've talked about this many times before. You need to set a proportion up because ratios are going to be the same. We always say that side lengths are proportional. Okay? So what I can do is this. I can say 10 is to, well, first of all, what does X have to correspond to? What distance? 12. Okay? I can say X is to what? 12. Okay, so I'm going to say X is to 12 as, give me another pair of sides that correspond to each other that you know the lengths of. 15 to 10. Okay? Now, when I get done with this, kids, just look at the diagram the way it is. My answer, we said X is related to 12. Would you agree with that? My answer in the end better be more than 12 or less than 12. It had better be more than 12 because X is part of which triangle, the bigger or the smaller. And if X corresponds to 12 right here and X is part of the bigger triangle, better be more than 12. Help me cross multiply and divide because I'm not very good at it. But I think 15 times 12 is 180 something. Okay, 180 divided by 10. 18. Okay, X is equal to 18. Do this for me, kids. That side is 18. Somebody have a calculator for me? Go 15 divided by 10 for me.
1.5.
Go 18 divided by 12 for me.
1.5.
Go 27 divided by 18 for me. 1.5. What's the scale factor go from the little one to the big one?
1.5.
What do you think?
Easy as possible. Gnarly.
Okay. You all right with that?
Yes, sir.
Okay. If you have to find a corresponding length, what do you want to try to set up? Proportion. Let's have you try one here. You guys, I think in the next one, you guys do the next one. I want to see how well you do with this one, okay? I want you to find the distance from S to T. This is an interesting one. You guys take a little bit of time, talk about it, compare an answer when you've got it or when you think you've got it.
It's 47.
No, it's not.
47. Yeah, it is. It is. I swear to God. It's 27. I didn't look. I literally tested. Yes, I did. I did. I swear to God. I swear to God on my mom.
What'd you guys get? 27. I'm hearing 27. Any other thing?
I used to play the game. I used math. I did not. Your paper was over.
All right, well, let's talk about it, kids. I'm going to go ahead and highlight what they said was similar first, okay? So they said UVW, so let's highlight UVW. That's everything on the outside, right? UVW is similar to what? QSR, right? Or QRS? Okay. Well, I have this side from U to V right here, kids. U to V right here. How long is that? And UV must match QR. What's S to T going to match? I'm sorry. What's this say again? Find the length of median S to T right here. S to T has to match what here? ZW. Okay. So if this is 12, this is going to be my X right here. So how'd you set your proportion up, kids?
X over 12.
X is to 12.
And then
36 to 16 would work. Anybody do anything differently? Did anybody call it 72 over 32? Could have. Okay. Do you guys agree that the X corresponds to 12 here? You agree that maybe this 36 corresponds to 16 here, if I would rotate it? I would be okay with that. When you solve that, what'd you get for your X value again?
27.
So it makes sense that 27 here would be more than 12. I'm going to do this another way. Take 12 and divide it by 16. What's your fraction? 3/4. And then take 3/4 times what value here? 36. Would that work?
I did 36 divided by 16 and then times that by 12.
That would work. 36. Okay, so listen to what I just said. I said take 16 divided by 12 and then times it by what? This divided by this times this. Isn't that like this times this divided by this? Kind of the same thing, right? That would work. Either way, what'd you guys come up with for a solution? Can you set proportions up using corresponding parts to find unknown lengths? That's pretty simple. Okay, there shouldn't be anybody in here that doesn't know how to do that. Okay, those should be easy peasy
Lemon squeezy.
points. All right, thank you, Frizz. Okay, so 27 is correct. How many had 27? I'm just curious. Okay, good with that?
I guessed it.
That's a good guess. All right, part four, modeling with mathematics. This won't take too long to do. How about a volunteer read my example for modeling with mathematics? Thank you, Michael.
Your neighbor has decided to enlarge his garden. The garden is rectangular with 6 feet and a length 50 feet. The new garden will be similar to the original one, but will have a length of 35 feet. Find the parameter of the original garden and the enlarged garden.
Okay, so what's the original garden?
6 feet.
Let's make the garden green today. Let's think green, because I'm ready for spring. Aren't you ready for spring, kids?
Too cold out.
Spring break?
Nah.
Here's my first garden, okay? It says the new garden will be similar to the original one, but have a length of what? Is the new garden bigger or smaller?
Bigger.
Okay, let's talk. The original garden is what by what?
6
By. The new garden's going to have a length of
35 feet.
35 feet down here, okay? It says the new garden will be similar to the original one. The original one's going to have a length of 35 feet. Find the perimeter of the original and the enlarged garden. Well, the original one should be easy to figure out, shouldn't it? What's this distance up here? 15. What's this distance over here? So the perimeter on the original one is going to equal, what's What's that going to add up to? 42 feet, okay? Now, perimeters, this is an interesting one. We can do this one of two ways, okay? There's a rule that says if you know the perimeter of one and you can find a scale factor, you can set a proportion up this way. What this means over here in this, these are two are similar. So it means for every 15 units of length down here, how many units of length will I have over here? So one way to find the perimeter here, kids, would be say, well, I could say for every 15 units in the smaller rectangle, there are how many units in the bigger rectangle? But the perimeter of my smaller one is how many units? So I would put that 42 up top or in the bottom here, kids. It's part of the small one. Do this for me, kids. Solve that proportion. 98. Okay, we get 98 feet for our perimeter. So the perimeter of the big one, I'll put P big like this, is 98 feet. You could have said, well, I already know the perimeter here, so I could say 15 is to 35 as the perimeter 42 is to the perimeter over here. Now another way I could have done it is this. I could have found the other side here. Is there a way to find this length right here? How much is it? It's 14. I could have said 6 is to, maybe I put an x right here. Maybe I said 6 over x equals what over what, kids? Maybe 6 over x equals 15 over what?
35.
And you would have found that x is equal to 14, so you could have gone 35 plus 14 plus 35 plus 14, and again you would have had what value there for a perimeter? 98. Okay, so the perimeter on this is how many feet? Okay. That's interesting. Now there's a big concept on the next page, and we need to be very careful on this next page. So first of all, are you okay about similar figures and finding side lengths by setting up a proportion? Okay. Last page is where things get tricky. Anybody need more time that page? Okay, here's where things start to get tricky, kids. We're not talking about sides. All of a sudden we start talking about what, kids? And not even angles.
Polygons.
Not even, well, kind of polygons. All right, let me do something quickly. Bear with me for a second. Good push.
Takes forever.
Okay, let's just talk real quickly, kids. Here's a grid right here. You see my grid? Here's a 1 by 1 grid. You like my 1 by 1 grid? That's 1 square, right? Okay. What if I choose to double that right here? What if I say, hey, you know what? Let's double this. Actually, let's triple the lengths on this. First of all, what's the area of this square? What if I go ahead and blow this up by a scale factor of 3?
Then it's 9.
It means triple this way and triple this way. So all of a sudden, if I take this, go 3 over and 3 up now, what's the area in yellow? 9. Okay. Did the area triple like the sides tripled, or did the area go up by more than 3? How much did it go up by if I went back? 3. Well, how about the area though? What's the area of this one green square? What's the area of really the yellow one? Okay, we only tripled the length. We didn't take the length times 9, we only took it times 3. But here's the deal, kids. When you think about area, you have to understand that area is what type of unit when you measure it. When I say the area of the carpet here is 28 square feet, right? Squaring is like what power? So anytime you're looking at something right here, going from side lengths to areas, you've got to take a side ratio and square it. So for instance, you agree that if I was just looking at the side, this would be 1, this would be 3 right here. Wouldn't the side ratio be, for every 1 unit of length right here, there are 3 units of length in the bigger one? So a side ratio would be 1 to what? But the area ratio is equal to the side ratio to what power? Okay, so what it means then when we start talking areas, it means for every 1 square unit that's green, it's like taking 1 squared, there are 3 squared units up here. So what's 3 squared equal? That's where that ratio is coming from. So in your notes on that last page there, what I want you to do, I want you to write this down. Okay. If you know the side ratio, an area ratio, whoops, didn't want to do that. An area ratio, I'm going to put it over here. Area ratio is a side ratio squared. Okay, so hear me out on this. An area ratio is a what? Side ratio really to what power? Okay. In diagram PQT, Parson QT, got it?
What?
P is QT.
We probably can't call our teacher Q. We probably get some rules.
Whatever.
Bartender, cutie.
Thank you.
I don't know about that.
Adam's over rapid right now.
All right. They're similar triangles, meaning these are triangles are the same, but what's true about their sizes? Okay. Right here it says the area of triangle RST is how many square units?
75.
On the inside here, there's how many squares here, kids? How many square meters are inside triangle RST? Okay, help me out with this, kids. We need to figure out the area in triangle PQT. Okay, now up there, guys, do we have 2 sides that correspond to each other? Okay, talk to me about this, kids. The side ratio is what to what? 14 to 10. Okay, now hear me out. I'm not going to tell you you have to simplify that side ratio. Again, what are we trying to find? Man, I tell you what, if you're looking for an area, wouldn't it make sense then to have an area ratio? Oh. Yeah, if I'm looking for an area, is a side ratio going to help me?
No.
I need what kind of ratio?
Poly ratio.
An area ratio, right? How am I going to generate an area ratio given a side ratio now? What's it say? So let's get an area ratio down then. So my area ratio becomes 14 squared over what?
10.
Okay, so the area squared. 14 squared for me, please. 14 times 14.
Could we simplify it and then
You could. You
It would
could.
be 7 and 5.
Yeah, you could do that.
That's a lot easier.
Well, do you want to simplify it?
Yeah.
Fine, that's fine. I'm telling you, you don't have to, but
Yeah, Adam.
okay. Area ratio is 7 to what?
Then it's 49 over 20.
So the area ratio would be 49 over what? 49 over what?
25.
So what that means is this. For every 49 squares in the little triangle, there are... I'm sorry, for every 49 squares in the bigger triangle, there are how many in a smaller one?
So then you just times that by 10
Yeah.
technically.
So technically, yes, but here's how I would do it. If I know that there's 49 units in the bigger triangle, for every 25 over here, I'm going to say, okay, my area ratio 49 is to 25 as, okay, do I know the area of this big one right here?
No.
Isn't that what we're trying to find? I can call this area X. Do you know the area of the smaller triangle, though?
Not if it's not from our head.
Okay. my area and the answer in going to be more than 75 or less than 75?
More.
If it's not more than 75, you've probably set your proportion up incorrectly.
147.
What do you guys get?
147.
Area here is 147.
Meters squared.
147 square meters.
Square meters. Meters squared.
Well, there's a big difference between that.
Meters squared and square meters.
2 square meters is not the same as 2 meters square. 2 meters square is 4 square meters. You can say 2 meters times 2 meters.
Good thing it's not a world fast.
Last example here. Decide whether polygons are similar. I gotta blow this up. I can hardly see this. Okay, you guys can read that on your paper, right?
Yes, sir.
Okay, here's the deal, kids. This is what I'm gonna set up. It says decide whether these are similar. They want to know, is GNMH similar to MLKH? Here's what I'm gonna set up. I'm gonna go with this part first. I'm not even gonna look at the diagram. I'm gonna go with what they want up here. So GN would correspond to what, kids? M what?
L. H. Wait. What?
Let's just do all the sides. Then NM would have to correspond to what? I'm reading these two right here. NM would have to correspond to what?
ML. Is there another letter somewhere missing?
No, I don't think so. They just, the side didn't get drawn in all the way. You might want to draw that in there. I don't know why they didn't do that. So NM corresponds to what, kids?
Okay.
All right, next side. M, does that say MH right there in your notes? So MH would correspond to what here, kids? And then finally, I have to go H back to G. HG would be the same as HM. Okay, here's what I'm trying to get at, kids. When they ask you, are figures similar, you want to show that the ratios of all sides are equal. Okay? And that can be kind of tough to do sometimes. But here's how we're going to do it. You ready?
Yeah.
Guys, what's GN's distance?
10.
10. So this is 10. What's ML? 4?
Hold on. Got
4.
Okay. So 10 over 4. We need to see if this is going to equal the other ratios. What's NM equal?
25.
What's LK?
10.
Okay, so that's that ratio. What's MH over KH? 10 over 4. What's HG over
25.
KL?
Over
10? Well, here's the deal. What's 10 divided by 4 going to equal? What's this going to equal? What's this going to equal? What's this going to equal? Since all those ratios simplify or divide out to be 2.5, are the figures similar? Yeah. All ratios are equal. Could I say all ratios simplify to 5 over 2? Is that okay?
Sure, you do.
So, we would say GNMH is what? Similar to which one? Everything's about proportions. The one thing that's tricky is this. When you start talking about area, what do you need to do to the ratio of the sides? Square them. Okay? With me? Okay. Come on, stop that recording here. I'm going to send out an online page here in a second, so get a little organized.